everybody, thanks for watching. In this video, I'm going to show you how metal and nonmetal atoms interact with each other, forming ionic bonds. Now before we get started with ionic bonding, let's have a quick review of some bonding basics, starting with the idea of valence electrons. When it comes to bonding, these are the most important ones because they're the electrons that are actually involved in the bonding process. And they're also the ones in the highest energy level s and p orbitals of an atom. So if we take these two electron configurations, sodium and bromine, and try to find the valence electrons, all you've got to do is go to the highest energy level. So for sodium, out of the first, second, and third, we'll go to the third and find the s and p orbitals there. So it's the 3s. Notice we don't include the p's here because they're part of the second energy level and we only go to the highest one. For bromine, that fills up to the fourth energy level. It does have s and p's in the fourth, so those would be its valence electrons. Once you know about valence electrons, you can draw electron dot diagrams, which is really just a much faster way of showing only the valence. If we don't care about the 1s2, 2s2, 2p6 for sodium, couldn't we only show its one valence electron? So you'd put one dot around the Na symbol, and for bromine's 2 plus 5, 7 valence, you would do 7 dots. And last but definitely not least is what these atoms do with their valence electrons. When it comes to metals like sodium, metals are always going to lose their valence electrons with the goal of becoming like noble gases, because noble gases are chemically stable. So with sodium's one valence, the 3s1 is going to get lost, it's going to go somewhere. If you were using an electron dot diagram, you'd see the one dot disappear and go somewhere. And what you're left with is an atom whose configuration now fills up to 2p6, like neon, a noble gas, so it is now stable. Another side effect of this is that the sodium has lost a negative electron, so its charge is now a +1, because it has one fewer negative particle. If you're a nonmetal, you're not going to lose electrons. Nonmetals don't like to do that. They actually prefer to gain valence electrons, but with the same goal, to be like a noble gas. So bromine, which only fills up to 4p5, if it could gain one electron back, then it would fill up to 4p6, which would be like argon, a noble gas, which again is stable. The same side effect happens, except in the opposite direction. Bromine has gained an extra negative electron, so its charge now becomes -1. The one piece of information we've left out up to this point is, where did sodium's electron go? Where did bromine get its electron from? If metals are losing electrons, where are they going to? And if nonmetals are gaining electrons, where are they coming from? And the answer to that question is ionic bond formation. So with that in mind, I think we're in a good place to start defining and looking at ionic bonds and what they are and how they happen. First of all, ionic bonds involve metal atoms transferring, that's an important word, transferring their valence electrons to nonmetal atoms. So we've answered that question of where do they go and where do they come from. They transfer them between each other and you form ions, and because those ions are oppositely charged, they are then attracted to one another. Let's take a look at that process with sodium and bromine, our examples from the start of the video. So remember, this sodium atom has a one extra valence it would like to lose. The bromine would like to gain an extra valence, so if a sodium atom and a bromine atom get near each other, that's exactly what they'll do. The sodium will transfer or give or donate its valence electron over to the bromine, changing the electron configurations of both atoms. Now once that transfer happens, there's some other things that take place that are also really important. First of all, the sodium becomes a +1 charge because it lost an electron. The bromine attains a -1 charge because it gained an electron, and now we've got two oppositely charged atoms that are near each other. So just like any oppositely charged particles, they're going to be attracted to one another. Let's wrap it up with some vocabulary you should be aware of when talking about ionic bond formation, the first of which is you're always going to have a positive ion, and we're going to call that the cation. That's the official term. You're also always going to have a negative ion, which we call the anion. Also notice the configurations of each ion are now matching up with a noble gas, making each chemically stable. The attraction between these oppositely charged particles is officially called an electrostatic attraction, which again is the ionic bond itself. And that concludes this video. Thank you very much for watching.